This is going to be my senior project on green roof technology. It's called the Geospatial Analysis to Determine Potential Green Roof Benefits on the Peninsula of Portland, Maine. Again, my name is Josh Plourde. Thank you, Dave, for introducing me. So I started my project. We were proposed to do a project on a plant, on an environmental issue to try and display that basically we learned anything in our 4 years of college here. So this is my project here. I used to live in Portland before I attended here at University of Maine at Fort Kent, and I wanted to focus on green roof technology. And so why did I want to go with green roofs? One of the main reasons why I wanted to deal with green roofs is because the wide range of benefits you can gain from this technology. We have recreation. We know people that like to go out there and sit in these office buildings that they have in these urban areas, sit down, enjoy lunch. Wildlife habitat, a lot of birds, a lot of different insect species can be found in these high-rise areas. Urban heat island effect. Studies have proven that when you increase the amount of green space in your urban area, you in fact actually lower the temperature of that area. In a urban heat island, we have a lot of concrete. We have a lot of surfaces that radiate heat, and in the nighttime, that heat is just radiated off and doesn't escape. There's no trans-evaporation. What I really wanted to focus on was stormwater retention. And the biggest thing about stormwater retention is when you have impervious surfaces like you do in an urban environment. So what I'm talking about that is surfaces where water can't seep through. Soil is impermeable, a permeable surface. So when it rains, the water seeps through, and it can replenish our aquifers and replenish our water table. So when you have impervious surface in a city, that doesn't happen. One of my main focuses was combined sewer overflow. What combined sewer overflow is when you have a system where you're sharing a sewer system of a public works, like a municipal, like a town or a city, and you also have the storm drain sharing that same pipe. This would be the outfall pipe. This would be coming into a harbor or a river, a bay. What happens when you have an extreme weather event, this can become inundated, and you can have sewer backup, and that release can be discharged into your harbor system, causing pollution, creating issues for the marine wildlife. So in Portland, it's a big issue. Portland currently right now, as of 2011, accounts for 44% of all CSOs by millions of gallons in the state of Maine. These are all the different cities that have CSO issues, and Portland is by far the largest. So why are CSOs even a problem? Well, the Clean Water Act stipulates that any discharge of a pollutant from a point source is illegal. And you must have a permit to enforce a technology-based standard to eliminate that pollution. All right, so it's costly to fix. Currently, right now in Portland, they spent $170 million is actually being spent on their tearing up all of the combined sewer overflow systems and replacing the new ones. And they've already spent $94 million to date. Now, they've had a 5-year permit, and this permit says that after 5 years, you must no longer be polluting, and they're still polluting, so they're trying to eliminate this problem, but it's costly to fix. So I want to try to look at other alternatives to just ripping up combined sewer systems. So when you talk about green roofs, you have two types of green roofs. There's an extensive green roof and an intensive green roof. When you think about extensive green roofs, you're looking at as wide of a surface area as you possibly can get. So this would be the top of the building. Is essentially the entire surface of the roof of the building is covered with a real low-growing sedum or moss. And these types of green roofs are very good for buildings that can't take a real heavy load. They're a thin soil medium, so your soil is only several inches thick. You can grow a wide variety of low-growing plants on top of there. Now, if you go to an intensive green roof, your intensive green roof is going to have all kinds of different types of things. You can have trees, you can have flowers, you're going to have a very deep soil medium, but you're going to have a building that can withstand that heavier load. So both intensive and extensive green roofs both have little similarities, and that's just basically in the way that they're constructed. They have all these similar layers: waterproofing membrane, roofing deck, a drainage layer, a root barrier, filter fabric. What the difference is the soil depth is going to determine what type of vegetation you can actually grow on top of it. So that's a little background there. Just get into what I was doing on my project. So I was going to use GIS to determine green roof area, and I was going to figure out how much green roof space that I could actually get in the city of Portland. I was going to be using ortho photos from the Cumberland County. This is from the main office of GIS. And what these were is essentially these photos right here that you see. These allowed me to zoom in, get on top of these rooftop buildings, and digitize what I had to do. I was using the coordinate system. Everything that I was digitizing, I had to be geographically accurate, so I was using the UTM zone 19N, and that's in the North American datum. And what this would do is once I created a polygon, which I'll show you, it will give me an accurate spatial area so I can put that in a geodatabase and determine how much total area I have what I'm creating. So then lastly, I had to digitize my roofs, and this is what I'd be doing. I'd actually go on there with a cursor, and I would be digitizing the areas on top of the roofs. So once I had this information, this is me in the summertime putting it into the program. This is the GIS. This is an older software, actually. I think this is ARC 9 or ARC 10. Now they have ARC 10.1. So this is what it would be like after I made all my I digitized everything, I put them into my geodatabase, and now I'm selecting all of the buildings that have a minimum of 350 square meters. And I decided this based on a study that I had seen in Ryerson University. They were using a similar standard, minimum buildings of 350 square meters with maximum coverage. So once I got this information, I was able to determine that I had 379 buildings fitting the above 350 square meter standard. And it gave me a total of 480,000 square meters, which is approximately 118 acres. Now I wanted to determine how much water is Portland getting, how much rain are they getting, what kind of effect does this have. So I tracked down the 30-year annual average precipitation and rainfall in Portland. And I was able to determine that 37.07 inches falls per year annually, per year on Portland. So now that I had my information, I had to start trying to make sense of this. I was able to use this formula right here that I had gotten online. And what this is basically doing is determining how many gallons of water an acre of soil will receive throughout a year, determined on how much annual inches of average rainfall you're receiving. So this bottom line right here is what I was focusing on, the gallons of water received annual by 1 square acre of soil. And with 37.07, I was getting 1,006,524 gallons of water. So I timed this by the amount of acres that I had in my area, and I determined that 119 million gallons of water could potentially fall over the area that I had in Portland, Maine of green roofs. This is about 19% of the total amount of CSOs that we have in Portland, so it's a pretty significant chunk. We could try and slow this water down. Perhaps we could eliminate some of these CSOs. So basically what this means is if you make some assumptions, Ryerson University suggests that up to 70% of all rainwater can be retained when you have 100% surface area on a building rooftop. So if we take that 70%, approximately 83 million gallons of water could be retained just by implementing some sort of green roof technology on top of these green roofs that I've digitized here in Portland. So that's about 17% of the total amount of CSOs that Portland experiences annually. So it's quite a large chunk. If you're teaming this type of technology with the technology that they're already trying to implement as far as replacing the combined sewer overflow system, there's a lot of benefits that can be gained. And this really doesn't even scratch the surface of lowering energy cooling loads for buildings because of the insulation effect that the green roof is giving, carbon sequestration, because we all know that green things sequester carbon and they provide oxygen. So there's a lot more benefits than just the stormwater. But this is my presentation. I hope you guys enjoyed it. I want to thank everybody that helped me out, and I will take any questions if there's any. Yeah.
Has Portland considered any green roof technology?
Say it again?
Has Portland considered any green roof technology?
As far as considering, no, actually there was last Scholar Symposium, we actually had a professor from the University of Southern Maine that was here talking about lead in the soil. And I had actually posed a question to her if she was working with the Public Works in Portland, if there was any discussion on green roof technology as a way of possibly getting people away from planting plants down in the soil on the ground that's high in lead and possibly moving them onto rooftop space. And she said that that had not been discussed at the time, so I don't know. Yeah?
What happens to those areas during the wintertime?
During the wintertime? You're going to have snow that's going to be on top of there. You're going to have snow that's going to be on top of a rooftop in, say, a white surface of a large flat roof building. A lot of flat roof buildings put that black surface on the top to try and attract that heat so it melts it off and the water will drain. But you also have a lot of newer buildings that are going with white surfaces that are flowing, so it might act as a different way. The building should be able to take that load, and that would be something that you would have to see if your building is even capable of taking that extra load. So, good question. Yeah?
Have there been any accounts that of bacteria or anything seeping through all the layers from the soil layer to the actual roof itself?
That I do not know. Anything that seeps down through the soil layer and gets down, it is all captured and is sent. So if the soil doesn't absorb all the water that's coming down in that rain event, it's designed to overflow and then to go through its natural runoff system. So like you would have a water capture or a water runoff system from any building. But this green roof is essentially trying to trap as much water it possibly can and preventing it from getting down to the ground level so that it doesn't inundate that system. Because once we get an inundation of water flowing into a river or a stream or any type of pipe, once it's moving too fast, that's when we have the flood events. The EPA said in a study that I wrote in Urban Lawyer in 2007 that if you take an area and add 25% of impervious surface, you take a 100-year flood event and now you make that a 5-year flood event. If you take it and increase it to 60% impervious surface, that 100-year flood event now becomes an annual event. So we've got to stop putting hard surfaces out there, and we've got to start embracing soft surfaces like grass and stuff that we can actually start building back our water aquifers, because we're losing our water table. So, yeah.
Okay, great. Just, it seems like there's a hidden assumption here. If you have a really, what you're saying, was it 70% of the water is trapped?
Right.
But that must be with a certain amount of rainfall.
Correct.
Right, and so.
They were those were in major storm events. Those were for like major rain events. Like not just like a light rain. If it's a light rain, any type of light rain that you would have, that's 100% absorption, and it's going to be absorbed by the plant material. Once you have like a major storm event where you're going to have like an inundation type of system, you're getting 70% of the water is being absorbed in that, and then everything is going out through the system. So,
please help me thank Josh for